Welcome to our Materials Science lecture on phase diagrams. In this session, we will explore the fascinating world of phase diagrams and their significance in materials science. By the end of this class, you will be able to determine phases present in a given temperature and alloy composition, understand the chemical composition of each phase, and calculate the weight fractions of each phase. Let's dive into the details with some practical examples. Here, we examine the eutectic reaction in the PBSN phase diagram. Notice the solubility limits and the eutectic composition. Understanding these reactions is crucial for predicting material behavior during cooling and solidification. The lever rule helps us determine the composition of phases in a two-phase region. By drawing an isothermal line or tie line, we can calculate the fraction of phases present based on the lengths of the segments. Let's characterize a 5% SN hypoeutectic alloy at 150 degrees Celsius. We will identify the phases present, their chemical composition, and the weight fraction of each phase. This process is essential for understanding the material properties. Now, we move on to a 40% SN hypoeutectic alloy at 150 degrees Celsius. Similar to the previous example, we will determine the phases, their composition, and weight fractions. This analysis helps in tailoring materials for specific applications. Phase diagrams are powerful tools that map out phases present as a function of temperature and composition. They help us understand phase reactions, such as eutectic and eutectoid, which are critical in materials science. Let's apply our knowledge to an 80 Wt% SN 20 Wt% Pb alloy at 150 degrees Celsius. Identify the phases present, the composition of alpha phase, and calculate the phase fractions. This exercise reinforces our understanding of phase diagrams. Continuing with the 80 Wt% SN 20 Wt% Pb alloy, we further analyze the phase fractions and compositions. This detailed examination helps us grasp the practical applications of phase diagrams. This concept map provides a comprehensive overview of eutectic phase diagrams. It highlights key points such as microstructures, properties, and the importance of eutectic reactions in materials science. Revisiting our learning objectives, we ensure that you can determine phases, understand chemical compositions, and calculate weight fractions in phase diagrams. These skills are fundamental for materials science. In Activity 3, we characterize a 40% SN hypoeutectic alloy at 150 degrees Celsius. This hands-on activity solidifies your understanding of phase diagrams and their practical applications in material characterization. Thank you for watching. Please like, share, and subscribe to our channel. Leave a comment below about what you learned and what topics you'd like to explore further. Your feedback helps us improve and provide more valuable content. This presentation contains copyrighted material used under the Fair Use Doctrine for educational purposes. All rights belong to their respective copyright holders. Links to relevant resources are provided in the video description.